Hello everyone, I am going to explain basic concepts of complex numbers. Part 2. Part 1 I already taught in my first video. So here we are going to start from the difference of two complex numbers. That how we can calculate the difference of two complex numbers. So if Z1 is A plus iota B and Z2 is C plus iota D, then how we can subtract them? So it's very simple. First Z1 minus Z2 just write down and write their values here. So Z1's value is A plus iota B, then this minus symbol, and then Z2's value is C plus iota D. So open the brackets. When you will open here the bracket, sign will change. After changing the sign, the real part with real part. Real part means which do not have iota. So A and C do not have iota. So write them together. And from this iota B and iota D, iota just take common. So in the bracket you are remain with B minus B. So this expression is named as the difference of two complex number. So the direct formula for difference of two complex number is this one. And how we have derived here? By these steps. So directly you have to learn this step. That is when you have to find the difference of two complex numbers, then real part of both the complex numbers subtract and iota just take outside, and the imaginary part of both the complex number subtract in the bracket. So I hope it's clear to you. Now we move to the second point of basic concept. So the second point is multiplication of two complex numbers. How we can multiply two complex numbers? So it's also very simple. First, just write down here Z1 multiplied by Z2. Dot means multiplication, and write them in the bracket, and dot multiplied by the second complex number. Now here, how we used to open the two bracket in same way. Just open the brackets. So from here, first I wrote here A, then with that attach this bracket, and then write here iota B and attach this bracket. So if you are carefully, if you have to observe it, you will find that simply I opened here the first bracket. I opened the first bracket, and with that the second bracket I attached. Now further we have to open the small bracket. So when we will open the small bracket, this A will multiply by C also, and A will multiply by iota B also. So like this, simply how we used to open the bracket. On the same concept, open the brackets. Both the brackets is open. After, when you will open the bracket, you will get this expression. Now here, now in these middle terms, you can find that iota is common. So take iota common. So here you are remain with in bracket AD plus BC, and here iota square. Now we have to replace the iota square value. So here I wrote it. Since we know that iota square is minus 1, why? Because iota is root 1. So if you will do the square in both the sides, root minus 1 square is only minus 1. So iota square value is minus 1 because iota is root minus 1. So iota square value replace here. After replacing it, now what you will find that this AC and this minus BD are the real part of this complex number. So AC and minus BD you just keep in one bracket, and this iota and the bracket you just write in the second place. So again it is arranged in the form of complex number. So it is the real part and this one is the imaginary part. So this is the formula for multiplication of two complex numbers Z1 and Z2. So it's a formula, you must learn it. And how we obtain this formula is very simple. By open the two brackets, we obtained it. So it's a formula. Now we are going to move for the properties of multiplication in complex number set. So as we just now in previous topic, we multiplied the two complex number and we found that the answer is again a complex number. So product of two complex number is a complex number. So it is closure property. Closure property means from the complex number you picked two complex number, and product again you obtained the complex number. So it is closed in the complex number set. That's why it is named as closure property. So closure property holds good in the complex number set. Now commutative property. So commutative property is also applicable in the complex number. Means if you multiply Z1 by Z2 or if you multiply Z2 by Z1, you are going to get the same answer. So the multiplication is commutative in the complex number set. Now associative law. Associative law for the multiplication. So if we have Z1, Z2, Z3 are the three complex number, and if you have to multiply all three complex number together, then firstly if you multiply Z1 and Z2, whatever answer you will obtain, that answer if you multiply by Z3, then the product is going to be similar with the second option. In that you are going to multiply Z2 and Z3 first, then whatever answer will come, in that answer you will multiply by Z1. Means if you will proceed by left hand side or if you will proceed by right hand side, in both situations answer is going to be same. So this is named as associative property. So multiplication is associative in the complex number set. Now existence of multiplicative inverse. So what is going to be the inverse of any complex number? So for that, if for every non-zero complex number, z is equal to a plus iota b. So it's a non-zero. Firstly, the complex number should be non-zero, and if the complex number is non-zero, then its inverse, multiplication inverse surely present, and that multiplicative inverse formula is going to be, first how we will represent it. So inverse, multiplicative inverse we used to represent by its reciprocal. So z's reciprocal is 1 upon z, that we can write as z in minus 1, and the formula is going to be like this: a upon a square plus b square plus iota, then minus b upon a square plus b square. So it's a formula for finding the multiplicative inverse of any complex number of the form a plus iota b. So you must learn this formula. And now we'll move for existence of multiplicative identity. So what is the multiplicative identity in the real number? That is 1, because if you multiply any number by 1, we used to get the same number. Its identity not used to change. Like for example, if you multiply 2 by 1, 2 into 1 is 2. In the same way, if you multiply 3 by 1, 3 into 1 is 3. That's why 1 is the multiplicative identity for the real number. In the same way, in complex number also 1 is the multiplicative identity. But that 1 we have to write down in the form of complex number. So just see here how to do the complex number 1 plus iota 0. So if you will simplify it, iota multiplied by 0 is 0, so it is only 1. So 1 we wrote in the form of complex number. So this is the multiplicative identity for the complex number. So just see what is written here. 1 plus iota 0 is called the multiplicative identity for every complex number z, such that if you multiply any complex number 1 plus iota 0, so 1 plus iota 0, if you simplify, what its value is going to be? It's only 1. So any number multiplied by 1 is the same number. So 1 plus iota 0 is called the multiplicative identity for the complex number. Now we are going to understand the distributive law. So if we have z1, z2 and z3, three complex numbers, then distributive law means you have to distribute it. So if z1 is outside and in the bracket two complex numbers are in either in addition or in multiplication or in subtraction, so when you will open the bracket, this z1 will move to the both. In the same like the real numbers, when we used to open the bracket, whatever be outside, it used to multiply one by one with all the numbers. In the same way, here also we will multiply z1 by z2, and then in middle plus sign, then z1 multiplied by z3. In the same way, it is named as front distribution. From front it is distributed to the inner terms of the bracket. Now from back distribution, if z3 is outside, then z3 will move first to the z1 and then z3 will move to the z2. So meaning is remains same, they are not different. So this is named as distributive law for the complex numbers. Now we will move to the division of two complex numbers. How we can divide two complex numbers? So if we have two complex numbers, that is z1 and z2, among them the divisor I took as z2. So z2 is non-zero because the divisor should not be 0 here. If it is going to be 0, then you know any number divided by 0 is infinity. So it's very necessary condition that whatever you will take in the denominator, that complex number should be not 0. So just put a simple condition that Z2 is not equal to 0. Then the quotient of Z1 and Z2, how to find it? Quotient means the division of Z1 and Z2. So for that, there is no option in the complex number. Simply what you have to do is just separate them as a product. So Z1 multiplied by 1 upon Z2. So here they are in division and here I converted them in the product. Now this 1 upon Z2. So 1 upon Z2 is what? It's multiplicative inverse of Z2. So write down it in the form of inverse, that is Z1 multiplied by Z2 inverse. So conclusion is, first you have to find out the multiplicative inverse of Z2, and whatever answer you will get, that answer you just replace here and then multiply Z1 and Z2. For division we don't have any option. Simply the division you have to convert in the multiplication. Now how to convert in multiplication? Whatever be the divisor, that divisor just write down in the form of multiplicative inverse. Then with the help of multiplicative inverse formula, first find out the multiplicative inverse of Z2, and then whatever answer you will obtain, that answer replace here. That is again is going to be a complex number. Now Z1 is also a complex number, and whatever answer you will obtain here, that is also going to be a complex number. Then apply the complex numbers multiplication formula and you can get the answer. So I hope it's clear to you. So we had studied just now the division of two complex numbers, that how we can divide two complex number. So that is only possible with the help of multiplicative inverse of divisor. Now the most important point, that is powers of iota. So very carefully just understand, because when we do the exercise, directly we are going to replace the values, that's why. So iota, you all know, iota is the square root of -1. So if you are going to do iota square, then what the value is going to be, that is iota square means root -1 multiplied by root -1, and you can see that root will remove each other, so you will get here only -1. In the same way, if we have to find out iota cube, then that we can write as iota multiplied by iota square, because if you will add the power here, you will get 3. So write it purposefully. Why? Because iota value we know, that is iota just write down as it is, and iota square just now we calculated, that is -1. So this iota square you just replace by -1. Then iota multiplied by -1 is minus iota. So iota cube's value is minus iota, which you have to learn. So three things you must use to learn. Iota is root -1, and iota square is -1, and iota cube is minus iota. Now iota power 4. So iota power 4 you can split as iota square multiplied by iota square. Now what is iota square? Iota square we calculated as -1. So replace here also -1 and here also -1. Now -1 multiplied by -1 is +1. So iota power 4 is +1. Now we are going to do iota power 5. Iota power 5 you can split as iota square multiplied by iota cube. Iota square is what? -1, and iota cube is what? Minus iota. That value just replace, you will get here again iota. Now students, you may note that now the values is going to be repeat, because you obtain here iota. So from here it's going to repeat again. So it's iota. Now in next step what is going to come? -1. So here just see we obtain -1. So after reaching to the +1, again the values are going to repeat in cyclic order. Now iota power 6 you can write as iota cube multiplied by iota cube, and iota cube is what? Here minus iota. So write here minus iota, and minus multiplied by minus is plus, and iota into iota is iota square, and iota square value is -1. So write here -1. So plus minus -1. So like this we can go, and now if it's very lengthy method, now if we have to generalize it, how we can generalize, how in easy way we can calculate the any power of iota in short way. Okay, so for that, so in general, for any integer of k, any integer of k means here, if we have any power, then how we can find it? So for that, the general formula you have to write down in the form of multiples of 4. the power we have to write down in the multiples of 4. Up to 3 there is no option, you have to learn. Up to 3 means up to power 3 you have to learn. There is no short trick for it. You must learn that iota is root minus 1 and iota square is minus 1 and iota cube is minus iota. It's very necessary for you to learn. And iota 4 is plus 1. And after this, since the values is started to repeat, so we can make the short tricks for it, but till iota power 4 you must learn the values. Now after learning the values, we are going to move for the generalization of any power. So these formulas are applicable if power of iota are either 4 or more than 4. So here if the power is in the form of 4 multiplied by any number, then we can write it as, we can split the powers. So 4 into k we can write as iota to the power 4 and whole to the power k, and iota to the power 4 is what? 1, and 1 power any number is going to be only 1. So iota power 4k is 1. So I hope it's clear to you. We have to split the powers like this and then we have to put the values. Now if the power is in the form of 4k plus 1, so how the power will convert, that we'll do in an exercise. Here only just learn the formula that whatever power will be obtained, and that power if we convert it in the form of 4k plus 1, then what is it's going to be the value. So just see here, I solved here in rough work. Iota power 4k plus 1. So powers are in addition means base are in multiplication. So I wrote the base in multiplication, that is iota power 4k multiplied by iota power 1. Power is nothing means 1 is here. Now iota power 4k is what? Plus 1. And iota is as it is. So 1 multiplied by iota is iota. So it is only iota. So means 1 means the power is, iota's power is 1, that is iota. Now in next you have, just see here, first you had plus 1, then you had plus 2 and then plus 3. So it will work as we had done here. Iota power 1 is iota only, then iota power square is minus 1, then iota power cube is minus iota. So that values are going to come here. So if power is 1 then iota, and if power is 2 then iota square is what? Minus 1, and iota power cube is what? Minus iota. So that values you have to replace. Now why it is happening so? The reason is here, because we can write this iota power 4k plus 2 as iota power 4k multiplied by iota square. Now iota power 4k is 1 and iota square we calculated initially, that is minus 1. So 1 multiplied by minus 1 is minus 1. So conclusion is iota power 4k is simply 1 in all cases. We have to only focus on this plus 1, plus 2 and plus 3, because iota power 4k is going to be plus 1. So if the power is plus 1, then it's going to be iota, and if power is plus 2, then iota square is minus 1, and if power is plus 3, then it's going to be minus iota. So like this we have to do. So these formulas are applicable if the power of iota is more than either 4 or more than 4. In that situation, convert each and every power in the form of these 4. Except these 4, you will not get any option, because students, you are going to divide the power by 4. So if divisor is 4, then remainder cannot be more than 4. It's a division rule. So it will be clear when we do the exercise. Now we will move to the next point, that is identities. So identities are similar, which we had learnt in our real number. That is, if somebody asks from you what is the formula of a plus b whole square, then what is going to be your answer? A square plus b square plus 2ab. So in that, simply a and b you just replace by z1 and z2, and same answer just write down. So z1 plus z2 square is z1 square plus z2 square plus 2 multiplied by z1 and z2. It is same like a square plus b square plus 2ab. In the same way, z1 minus z2 square is the same way as a square plus b square minus 2ab. So it is similar with a minus b whole square. Now z1 plus z2 cube is also similar with a plus b whole cube. So here student, it's in correction here, make it cube here. So it's going to be z1 cube, and here also z2 cube will come. So make it correct here. It's going to be z2 cube, and then same in the same way z1 minus z2 cube is also z1 cube minus z2 cube minus 3 z1 z2 multiplied by z1 and z2, and it will work as a square minus b square. A square minus b square is a minus b and a plus b. Now the next point is modulus of a complex number. Modulus of a complex number is very new topic for you, because earlier whatever we had done, that is subtraction, multiplication, division, it is already present in real number. So somehow they are resemble with the real number, but modulus concept is not present in the real number. So from here you have to learn a new thing. So to find out the modulus, see here, let z is equal to a plus iota be a complex number. Then modulus of z is denoted by, so modulus of z, the short notation in mathematics is like this: two bar you have to put and z you have to put. So it is mod z, which you already had in real number, but that meaning is totally different. So modulus of any complex number, if you have z as a plus iota b, then modulus we used to represent like this: two bars, and in between z is going to be square root of real part square plus imaginary part square. So it's the value of modulus of z, that is square root a square plus b square. So it's a formula to find out the modulus. Now properties of modulus of complex numbers. So if you have two complex numbers z1 and z2, and you have to find out their multiplication and then modulus. So you can find by two ways: either first multiply z1 and z2 and then find out the modulus, or first find out the modulus of z1 and modulus of z2 and then multiply them. Meaning is going to be same. In the same way, if we have to find out the modulus of division of two complex number, so you have two options: either divide them and then find the modulus, or first find the modulus of each complex number and then divide them. So in both way you can calculate, and the value is going to be same. And here you already knew it, that the denominator cannot be 0, because if denominator is going to be 0, then it will convert to the infinity. Now the next new topic, very new topic, that is named as conjugate. Conjugate of complex number. So let z is equal to a plus iota be a complex number. The conjugate of z is denoted by z. On the top you have to put a horizontal line. So this is named as conjugate of z. So how to read it? Conjugate of z, and is defined as. Now how to find out the conjugate? So in conjugate you not have to do anything. Whatever be the sign in middle, that sign just reverse. So if you have plus sign, then write here minus, and if you have here minus sign, then make it here plus sign. So it is named as conjugate of z. Now properties of modulus of it's not modulus, it's I think conjugate. So here also students correction is there. Make here conjugate. Properties of conjugate of complex numbers. So in conjugate, if you have to find out the product of two complex number and its conjugate, then you have two options: either first multiply them and then find the conjugate. So what is the meaning of this? First multiply, then whatever answer will come, find out its conjugate. Or here in right side, first find the conjugate of z1 and find the conjugate of z2 and then multiply them. The meaning answer is going to be similar. In the same way, if you have to add and subtract of two complex number and you need the conjugate of that result, then you have two options: either first add and subtract two complex numbers and then find the conjugate, or first find the conjugate of each complex number and then add and subtract. The meaning is going to be remain same. So these are the formulas, you all have to learn it. And then if we have to find out the conjugate of two complex numbers division answer, then you have two options: either divide them, divide the two complex number, and whatever answer will come, that answer's conjugate you just find out, or find out the conjugate of each complex number and then divide it. In both the situation you will get the same answer, and here denominator is not equal to 0. So, and these notes I made from the 11th class NCERT book. So now to do the exercise 5.1, all basic concepts I already explained. Now in next video we are going to start exercise 5.1, and after doing the 5.1 exercise, again some more formulas are there that we'll make, and I will upload that, and then we'll do the exercise 5.2. So after this video we are going to start 5.1 exercise. So I request from you all that whatever be the formulas are needed to do exercise 5.1, I already mentioned everything, and which are available in your NCERT book. So learn it so that easily you can understand exercise 5.1. Thank you.